By this point, you should feel comfortable with solving just about any kind of equation that has exactly one variable. Unfortunately, things don't always go according to plan with math. Sometimes things happen that shouldn't. Sometimes the variable subtracts out. And when this happens, we have to have some way of handling it. Now, when this happens, that means you're not getting a single answer. X doesn't equal a certain thing that unlocks the key to the equation. Things are a little different. That means you either have infinite solutions, which means that every value of x actually solves the equation, or you have no solution, which means that no values of x solve the equation. Nothing you can plug in would make both sides true at the same time. You'll recognize infinite solutions because you'll end in something called an identity, where you get something like 0 equals 0, 2 equals 2, 3 equals 3, 4 equals 4. If you get a number that equals itself, you can't get anything more true than that. And because it is always true, any value of x will solve the equation. No solution happens when you get two constants that do not equal each other. Maybe 0 equals 1, maybe 3 equals negative 5, maybe 7 equals negative 23. Whatever, the point is that it has no solution because those two sides do not equal each other. Now be careful, if you get x equals 0, that is not either of these. That is not this, and it is not that. X equals 0 is a perfectly okay answer to get. There's nothing wrong with that whatsoever. It's when you get two constants that don't equal each other that you are in trouble. So let's begin with example 1 here. With example 1, I'm going to subtract 2x from both sides. And we see here that we get 5 equals negative 1. And this is a case of the second example. We call this a contradiction. A contradiction is a statement that is never ever true. In this case, we say this has no solution. In WAMAP, you'll want to type it in using the letters D and E. D and E stands for does not exist. That means that there is no solution that can satisfy this equation. So you'll type D and E for does not exist. Let's take a look at example 2 over here. 3x minus 9 equals 3x minus 9. Well, if I subtract the 3x's from both sides, you can probably see where this is going. Now we get what I called an identity, a statement that is always true. A contradiction is always false. That's what we saw in example 1. An identity is always true. And this actually means we have infinite solutions. This means that no matter what I plug in for x, both sides of the equation check out at the same time. If I plug in x equals 4, that checks out. If I plug in x equals 3, that checks out. If I plug in x equals pi, that checks out. So that has infinite solutions because every x value works. To type that into WAMAP, you're going to type the infinity symbol. Unfortunately, the infinity symbol is a little unwieldy to type in, so instead just use two lowercase o's. We use those to stand for the infinity symbol. So remember, D and E for when you have no solution, two lowercase o's for when you have infinite solutions. Let's see how examples 3 and 4 work out for us. So again, I'm going to do what I did with example 2. I'll start with the distributive property. We have 6x plus 3 equals 6x plus 2. We see here that we get 2 equals 3. So just as with example 1, we have no solution. Now for example 4, again, we distribute. We will have 4x plus 1 is equal to 4x plus 6 minus 5. So this gives us 4x plus 1 equals 4x plus 1. And again, you should start to see where this is going. If I subtract 4x from both sides, we get an identity. We get that 1 equals 1. That means every value of x works. You could plug in any number for x, and both sides of this equation would be true at the same time. So we would say there we have infinite solutions. And again, in WAMAP, you would type two lowercase o's. So get some practice at making sure you can tell these two cases apart. Look at examples 1 and 3 and how they ended. Look at examples 2 and 4 and how they ended. Make sure you can see a distinct difference there. And that should be all there is to this.